The first question to ask when we want to calculate a freezing or boiling point is, what is the molality of our solution? So we're asked the molality of the solution given, which contains 2 kilograms of ethylene glycol in 5 liters of water. So ethylene glycol will be the solute. Our molality is solved by calculating the moles of solute and dividing that by the kilograms of solvent. So first of all, our solute, the amount of solute we have, the mass of solute is 2 kilograms. We want to convert that to grams because the molar mass is in grams per mole. So we put our conversion of grams to kilograms, and then we divide by the molar mass being in grams per mole. That's the molar mass that you've been given for ethylene glycol. All of that needs to be divided by the mass of solvent in kilograms. We know we have 5 liters of water. We will convert that to milliliters because our density of water is in grams per milliliter. We then multiply by the density, grams per milliliter. And finally, we want kilograms for our mass of water, so we put in the conversion of grams to kilogram. Check the units. We have moles of solute on the top. We have kilograms of solvent on the bottom. A lot of units there to keep track of. Now you just do the math, and we have the molality of our solution, or the molal. Check the significant figures. We know that we have 5.0 liters of water. That's only 2 sig figs, so we should come up with a final answer with 2 sig figs. So we round off our answer and are left with 2 significant figures. From this point, we can now calculate the freezing point. We simply use the freezing point depression equation to calculate the delta TF. We use the freezing point constant of water, Kf, times that molality that we calculated earlier. Keep track of the units here. So the freezing point constant is in degrees Celsius per molal. So then you realize that by multiplying by the molality, you're going to be left with degrees Celsius. So that will assure you that you've remembered the equation correctly if you check those units. Don't forget, that's the change in temperature. The actual freezing temperature then would be the freezing temperature of pure water, TF naught, minus that freezing point depression. And it's a minus here because the freezing point is depressed or lowered. So we're going from 0 degrees Celsius, which is the freezing point of pure water, minus that 12 degrees, which is the depression. So we're down to minus 12 degrees Celsius. As far as the boiling point goes, we use the analogous calculation for the change in boiling point, or the boiling point elevation, using this time the boiling point constant of water. Same units, you'll notice, degrees Celsius per molal. So we verify that multiplying by molal will give us an answer in degrees Celsius. This, remember, is the change in boiling point. And so in order to calculate the actual boiling point, we have to consider that that's an elevation. So we take the boiling point of pure water, TB naught, and we add to it the change in the boiling point. So we have 100 degrees Celsius, the boiling point of pure water. We add the 3.3 degrees Celsius, which is the elevation or the change, and we have 103.3 degrees Celsius.